さあ、それでは皆様大変お待たせをいたしました。ここからは2023年の本表彰受賞者の皆様よりご講演を頂戴いたします。はじめにフレキシブルナノ粒子触媒技術を用いたナノ肥料の開発と題しまして、マレーシアのカリサニ・ハリダ様にご講演いただきます。ハリダ様、よろしくお願いいたします。
Testing. All right. Okay, first of all, thank you for having me here. I'm feel appreciated to be here today in this stage. So the research that I want to present today is development of nanofertilizer using flexible nanoparticle catalysis, or we can call it flex nanocat technology. Fertilizer overview. In fertilizer market trends, it can be foreseen that the price increase from time to time. It will be expected in 2030, the price will surge very much. And also the problems. The high cost of natural gas, others cause fertilizer price increases. And also Europe, it has been expected that fertilizer shortage for farming in Europe. So the solution is the low-cost nanofertilizer production process through flexible nanoparticle catalysis technology. And the current projection of nanofertilizer trends in future increases. So there is urge to find a new technology to produce fertilizer at low cost. These patented process objectives are, we are going to convert big molecules to smaller molecules, which is in a nano form. And the small molecules will retain its ions capabilities like big molecules. And also, it will give a great impact of nanofertilizers on crops and environment. Basically, this work relatively takes 10 years of R&D, where the first stage, we develop a kinetic probe for the determination of ion exchange constant, KXBR, or relative counter ion binding constant, RXBR values. Then, in second stage, we determine ion exchange constant, KXBR, or relative counter ion binding constant, RXBR values for different salts. The different salts is actually the nutrient itself, yeah? And pK and others. Then, we understanding the effects of salt on the transformation of micellar structures. So we have a micelle, then with the addition of salts or nutrient, it converts to spherical, then worm-like and vesicles. Then we study the development of the modification process for colloidal fertilizer to nanofertilizer and retaining the affinity of ion exchange constant, KSBR, or relative counter-ion binding constant, RXBR values for large unilamellar vesicle micelles. So we have the so-called the nanofertilizer system. What we do next? We test in a small-scale assessment in MARDI on the effect of modified nanofertilizer on crops by me and my team. And then for the large scales, we did the assessment for the effects of modified nanofertilizer on crops by commercial partners. Yeah? And it's improved up to 25%. So this basically the innovation process that I skipped due to time constraints. Yeah. So this is basically how I did the research and everything. But then we hope that in future the potential stakeholders will be the companies around the world. And I look at failures as a fertilizer to success. So fertilizer has a lot of problems. That's why our research are intended to improve the capabilities of fertilizer for the state of the nation. The competition analysis, what good about this technology? This technology needs cheap equipment, simplicity of the process, and low-cost production. What is the game changer of this technology? What is important? It's low cost. It reduces the cost of fertilizer production. We know fertilizer production process is very, very, very expensive. So we convert these big molecules to only the small molecules, but it has a high capability and high efficiency. And it's also a direct conversion. The direct conversion of conventional fertilizer to nanofertilizer. We will not have a problem of the source of fertilizer itself. We just convert the conventional to nanofertilizer. And then we multiplying the molecule itself. We multiply the fertilizer molecules and we improve the properties of foliar fertilizer system. So we predict it will expand to the whole nation, and it is a moonshot project. Basically, we have commercialized it to the companies named KPG Resources, and this is one of the products. They will produce another product itself, and the patent is granted, and it is registered under Malaysian intellectual property. And it is a moonshot project also, where it has been highlighted in media, and also it has been highlighted in a scientific discovery channel. The series is called Amazing Nano. You can find it in the YouTube, indeed. Yeah. This technology has a greater impact for other industries also, because we multiplying the molecules. So it's not only fertilizer. We can use this technology in surfactant and detergent industries, polymer, healthcare, oil and gas, food and beverage, pulp and paper, textiles, and paint coatings, because we deal with micelles, where we carry all the nutrients in the micellar form. So in conclusion, this technology is low cost, low liabilities, and high equity. Without further ado, I would like to thank to you all, and also I would like to thank MARDI, especially our Director General, Dr. Muhammad Zabawi, and also MARDIans who helped me in the success of this work, and also the Embassy of Malaysia, and also my commercial partner, Mr. Amabusu, for doing this success. And without further ado, I would like to end my presentation with a big thanks and arigatou gozaimasu.
ハリド様、ありがとうございました。ハリド様よりご講演いただきました。ありがとうございました。では続きまして、インドの半乾燥・半湿潤地域における環境に優しい土壌健康管理戦略の開発と評価と題しまして、インドのアビジット・ゴーシュ様にご講演いただきます。では、ゴーシュ様、よろしくお願いいたします。
Hello. Very good morning, ladies and gentlemen, to all of you. At first, I would like to thank the chairman of the selection committee for choosing my work as one of the eligible work for this award. And I also would like to express my sincere gratitude and thanks to the chairman of the Ministry of Agriculture, Forestry, Fisheries, President Jirkas, and Chairman IFPRI for the great hospitality and award here at Japan. So basically, I am a soil scientist working on land degradation and restoration to improve the livelihood as well as the productivity of the degraded land. Presently, in India as well as the globe, the soil is being considered as a service provider, and soil provides many services. Among them are food production, maintenance of soil biodiversity, natural biodiversity, as well as nutrient recycling and water recycling. And when it comes to me, I see the soil as a provider of three important services. They are the provisioning services, regulating services, as well as supporting services. The basic focus of our research is to develop a greater resilience in the soil system through ecological designing, while we care for the natural heritage as well as social identity in India. Our major focus is to develop effective soil conservation strategies as well as new computational technologies, and impacts of human activities as well as wildfires on the new biogeochemical cycles of the elements is also important to understand, and we specifically recognize the microplastics as a global threat and as well as a national threat to the food system. The development of green technologies for soil rehabilitation is also an important aspect for our country. Nearly more than 100 million hectares of Indian land is degraded, and it has also major problem of declining soil organic carbon and dangerously negative or low nutrient balance. But our dream is to achieve carbon neutrality by 2070 in agriculture. The basic focus area of my research work is the Bundelkhand region of India. It has a very low rainfall and very high temperature during summer and a very low temperature during the winter. And the region suffers a severe state of land degradation, and the economy is mainly supported by the livestock production and the small scale dairying by the local poor, resource poor farmer. So forage production and fodder supply to the animal is an important aspect in that region. So our focus is to develop strategies so that land and soil health are maintained to support the rural people and animal with the fodder. For this, we developed several silvopastoral system, hortipastoral system, grazing management strategies, pasture land restoration and rejuvenation, as well as several waste management strategies. This is a basic work covering approximately 12 hectares of land, where we developed different silvopastoral system involving several trees like Ficus infectoria, Morus alba, Acacia nilotica, and Leucaena leucocephala. And the impact of land restoration is outstanding. The silvopasture-based land restoration system improved the soil biodiversity, as well as it facilitated the soil carbon sequestration significantly, and it improved the eco-restoration efficiency of the land significantly. Ultimately, the silvopastoral system could facilitate to the diversified crop production and reduce economic vulnerability as well as climatic vulnerability in the region, and it improved the carbon sequestration as well as soil nutrient availability, and also improved the nutrient recycling, and ultimately it aided in improving the economic efficiency as well as the cost of the livelihood status of the Indian people. And ultimately it has the potential to achieve few of the sustainable development goals, like sustainable development goal 1, 2, 8, 12 and 13. And the next one we attempted is hortipastoral system involving fruit trees having Pseudium guajava and Emblyca officinalis as a fruit component, and the understory and the in between the rows there were grasses were established as a fodder sources to the animal. And to provide the moisture to the system, we also went for the staggered contour trenching, and the result is here. The hortipastoral system with staggered control range improved the soil quality index, soil enzyme activity, the soil functional biodiversity, as well as the microbial population and their carbon nitrogen content, and ultimately it improved the soil organic carbon, that is carbon sequestration in the soil. So as we see this graph, we can claim that with the passage of time after the restoration, after the initiation of land restoration activity, there is an increasing increasing trend of services, of ecosystem services, like the hortipastoral system. First, it improves the soil moisture as well as structure, and then it improves the microbial activity as well as the biomass production, and ultimately it improves the economic efficiency and the income of the local people, and it ultimately motivates the local people and the local farmers to achieve and promote the hortipastoral system. And grazing is also an important aspect for the local people, but uncontrolled grazing can cause severe degradation of pasture land as well as greenhouse gas emission. So controlled, we imposed and designed a low intensity rotational grazing to solve the problem. And this is the grazing strategy we designed, where a part of the year, during a part of the year, animals are allowed to graze in the pasture land. And the green part is the portion where we don't allow the animal to graze in the pasture land, but we feed them through cut and carry method. And during the grazing, the surface cover is reduced, and it exposes the soil to rainfall, water, and wind, which may cause the soil erosion. But the litter input from the animal, it also acts as a source of nutrient to the soil, and it changes the biogeochemical cycles of the nutrient, and it helps in the regrowth of the biomass, which helps in the growth of the pasture biomass and allows grazing again. If we can see the right-hand graph, we can see that as we impose grazing, the litter input and the carbon nutrient input are there, and it improves the nutrient status of the soil. But as the grazing is withdrawn, the biomass is regrowth. Biomass takes regrowth, and then it allows again to graze by the animal, and the cycle goes on yearly. And pastoral restoration and rejuvenation is an important aspect in India to restore the degraded land. As we see, the degraded land in India, where approximately 80 hectares of degraded land was restored and through the seeding of grasses like Megathyrus maximus, Stylocenthus cebrana, as well as the Cenchrus ciliaris. And after 3 years of restoration, we measured the difference in the carbon sequestration, and the difference carbon sequestration can be used as a carbon credit for the local poor farmers, so that they can get the additional income as well as contribute to the protection of the environment significantly. And we found that after 3 to 4 years of restoration, it has the potential, the grassland restoration has significant potential to improve the biomass production as well as the fodder production, as well as soil organic carbon and soil functionality by 4.2 to 6.3 fold nearly. And the fourth basic principle to improve the restoration we identified is restrict grazing. We initially did not allow grazing for two years, but the animals, we involved the local people to cut and carry the biomass or the fodder from the restored land to feed their animal. And then regular monitoring of the scientific team were taken care so that the appropriate measures can be taken. We also quantified the soil functionality of the eco-restored land using Legionella-leucocephala-like system, and then we found that the legume tree-based restoration activity has a great contribution in improving the soil functionality. We also estimated the ecosystem services of the range grasses during after land restoration. And they showed great proficiency in improving the carbon accumulation, nutrient cycling, and biological soil biodiversity. We also attempted to manage the agro-waste by developing a new tree gel from rice straw to protect, to prevent its incineration, and it has the potential to reduce the 25% of the fertilizer consumption and leading to reduced cost of cultivation and boost the economic profit to the farmers. And we also used a rice straw as a natural source of silicon. When we apply rice straw along with the phosphorus solubilizing microorganisms in the soil, it helps in reducing the phosphorus adsorption, and it enhances the desorption of the adsorbed phosphorus, which can, thus the rice straw plus phosphorus solubilizing microorganism application can effectively reduce the phosphorus fertilizer application by 25% to improve the soil health, microbial biodiversity, as well as it reduces the fertilizer import burden. Our larger aim is to achieve the sustainable developmental goal and food and fodder security. At last, I would like to thank our Director General, Indian Council of Agriculture Research, New Delhi, Ministry of Agriculture, Farmers and Welfare for funding our research, and Director ICAR, Indian Grassland and Fodder Research Institute for nominating me in this award. I also thank my family, friends, my scientific advisors, and JIRCAS as well as MM, the President JIRCAS as well as the whole family of JIRCAS for their great hospitality and the award. Thank you. I am really honored for this award.
ゴーシュ様、ありがとうございました。アビジットゴーシュ様よりご講演をいただきました。ありがとうございました。それでは続きまして、アフリカにおける改良作物品種の採用による小規模事業化の改善と貧困削減と題しまして、カメルーンのマーティン・ポール・ジュニア・タベ・オジョン様にご講演いただきます。
You're great. Okay. So sorry for that. Thank you for coming to listen to me talk. Well, virtually, I'll take you to 5 different countries in Africa. We'll be talking about how the adoption of improved legume varieties really contributes to improving smallholder commercialization and reducing poverty. So I want to begin by thanking the award committee for choosing this work, for selecting this work among one of the 3. And it's a lot of pleasure to me, given that I'm one of the first, actually the first economist to get awarded beside many natural scientists. So I also want to thank the International Food Policy Research Institute, where I used to work 2 years ago, for recommending me or for nominating me for this award, and also my current employer, the World Bank Group, for allowing me to come present here. So just by way of motivation, poverty continues to be a very big issue in many developing countries. And if we look at the second graph, unlike in other regions of the world where poverty has been improving, poverty has been increasing in Africa. And if we take the case of COVID-19, which has really rolled back many years of development efforts kind of in improving poverty and making sure that households are getting improved welfare. But just talking about poverty from an African perspective, one way to really reduce poverty is relying on agriculture, given that many of households rely on agriculture for food, employment, livelihoods, and a lot of purposes. But unlike other regions in the world, agricultural productivity seems to be very low in Africa. And if you look at just the first graph, the key engine to low agricultural productivity in Africa, it's really just land extensification. So we don't see a lot of intensification. We don't see a lot of use of improved seeds. We don't see a lot of use of fertilizers. We find that farmers are really just deforesting a lot of land to improve agricultural productivity. But that is not subsistent. And given that there's been this big push to kind of move smallholder farmers from low productivity subsistence agriculture to high productivity market-oriented agriculture. And one key thing when we talk of improving productivity is that many of researchers have learned from the successes of the Green Revolution from Asia, which really improved agricultural production and was able to have ensuing impacts on food productivity, but also to reduce poverty. So the Green Revolution really just entailed the use of improved seeds, improved fertilizers as a way of increasing agricultural productivity. And given this introduction, I stepped out possibly 7 years ago in 2016 when I was just doing my master's thesis at the time as a student in Germany, to understand the adoption of improved legume varieties. And by legume varieties, I'm referring to 3 legume varieties: chickpea, but also groundnuts, what people also call peanuts, and common beans. And directly, I was examining how these improved crop varieties relate to productivity, but also consumption, given that a lot of households consume these varieties, but also commercialization and in reducing rural poverty. And as an extension, I was also trying to highlight various possible heterogeneities and kind of sustained adoption effects. So just so that if I get caught up with time, this is a big preview of some of the findings from this big research agenda I set out to do 7 years ago. So I see that the adoption of improved legume varieties really increases land productivity, that is yields. It increases consumption, that is also, and it increases smallholder commercialization with impacts on poverty. Adoption also increases food security. And one key thing, we find that land productivity really mediates the relationship between the adoption of these improved varieties and commercialization. And we find that households that keep on adopting this improved variety, they see greater yields, greater consumption, and greater commercialization gain. And one key result for policy is the fact that we always are so concerned about whether these improved technologies really benefit smallholder farmers. And one key highlight from my research agenda is the fact that the adoption of these improved legume varieties really benefits smallholder farmers as compared to very large farmers. So the improved varieties we are talking about, like I mentioned, are just 3 legume varieties: groundnuts, chickpea, and common beans. And these legumes have a lot of special traits. Firstly, they are high yielding, but also they are pest and disease resilient. And we talk of pest and diseases, we see that with the advent of climate change, the incidence of pest and disease really increases in agricultural production. But also these improved varieties have special market characteristics such that farmers can take these varieties directly to the market. But given that these varieties are also drought resistant, they offer us the triple wins of climate-smart agriculture, that is increasing agricultural productivity, but also increasing resilience and reducing the emission of greenhouse gases. And given that these are legumes, we argue in our paper that they are really poor, that is very close to the smallholder farmers, and environmentally friendly because they sequester atmospheric nitrogen, which they use to increase soil fertility. And just a conceptual underpinning of the work. So I set out to do this by referring to the non-separable agricultural household model, where the production and consumption decisions of households are non-separable. So you cannot separate production from consumption. Households produce to consume, but the consumption decisions also influence production, and then it also influences market commercialization because households would only go to markets to the extent that the household food demands are met. So assuming that a farmer produces groundnut, he or she would only sell after satisfying his or her household demands. But in taking these products to the market, households face a lot of transaction costs, bad roads, but also different aspects of middlemen. And we see that these improved varieties really reduce some aspects of transaction costs, that is search costs, because the quality of these improved varieties are high. Traders come directly to the farmers, but also farmers don't face a lot of this negotiation and bargaining cost. It's kind of less, and also their sorting and time implications are really small. But also these improved varieties could really just improve agricultural productivity directly and reduce productivity, but also gender gaps, given that the cultivation of some of these crops, especially beans and groundnut, have been defined or have been described as women-sensitive crops. So for our data, I relied on 5 different country case studies: Cameroon, which is in Central Africa, Ethiopia, which is in East Africa, then Ghana, Mali, and Nigeria in West Africa. And for this, I utilized farm household surveys, where in some of these household surveys, we went to the same farmers repeated over a period of 9 years. And the production systems for most of these countries were just legume-based production systems. Like I said, legumes are really close to smallholder farmers. They are poor, but also environmentally friendly, and they're a big source of proteins for households that cannot afford to buy meat and fish, especially in smallholder communities. And just a brief description of what we find, especially in Ghana, Mali, and Nigeria. We see that over time, between 2017 to 2019 on this data set, adoption really increases. There's a lot of heterogeneity, and it's considerably low. And if you check a country like Mali, you find that in all the years in 2018, you find some really decreases, which really explains lack of access to seed systems. But also just introspecting and looking at some of the characteristics of households that are adopting these improved varieties versus households that are not adopting these improved varieties, we see that households that are adopting these improved varieties produce more, right? So their yields are more, but they also commercialize more. So they produce more, and because they produce more, they can also sell more in market and earn income from their commercialization. And most of this work has been published. Like I said, it's work I started 7 years ago, and a lot of it has been published. And I'm just going to highlight some of the key findings from some of the published work. So this one was published in Nature, and I was really happy that the work got into Nature. Nature is one of the best journals when it comes to scientific publications. And in West Africa, we see that the adoption of these various climate-resilient groundnut varieties really increases production, but also commercialization and smallholder commercialization. And also in Cameroon, we see that the production and consumption and diversification of grain legumes really depend on a lot of different characteristics, but the adoption of these improved climate-resilient varieties really increases all these aspects of smallholder commercialization. And really in some work from Ethiopia, we also see that the adoption of improved chickpea varieties make farmers to commercialize more. So I'm going to get into these findings more, hoping that I have some time. So when we talk about adoption, we're considering both how much farmers are adopting, but also what is the area under adoption. So we see that farmers who are adopting these improved varieties under a greater acreage of their lands, we find increases in production, but also increases in the consumption of these improved legume varieties. Like I mentioned, these legume varieties are really highly proteinous and really available for households that do not have the income streams to kind of buy meat and fish from markets. But also, we see that when we look at both the extensive and the intensive margins, adoption increases commercialization. So by the extensive margin, we mean households that just participate in markets, but also by the intensive margin, we really talk about the market surplus. What quantity of legumes are you selling in market? And we find all these increases. But also, thirdly, we see that households that adopt these improved legume varieties over time, they obtain greater production, consumption, and commercialization. And looking at some quantile effects, we see that adoption really benefits smallholder farmers. So this really speaks to aspects of inclusivity. So smallholder farmers are really included in this drive towards improved commercialization and reducing poverty. And talking about food security impacts, this is also work that just got published, where we showed that the adoption of these improved climate smart agricultural practices increases food security through food consumption in Ghana, as you can see. And in Ghana, Mali, and Nigeria, farmers are combining the adoption of these improved crop varieties with legume, maize intercropping, but also the use of organic fertilizers like manure. And in terms of commercialization and poverty, in Ethiopia, we see that agricultural commercialization, that is households who commercialize their products, they see increases in livestock accumulation and assets. And in many of these smallholder communities, livestock assets represent considerable rural wealth. So we find that commercialization really reduces poverty and increases the amassment of assets, which households can use to smoothen consumption in times of different crises, including just the recent COVID-19 crisis. And just a discussion of the results, we kind of push that there should be the upscaling, there should be the development, and there should be the dissemination of improved crop varieties, as they have the probability to trigger agricultural transformation, that is, take smallholder farmers from low productivity to high productivity market-oriented agriculture. But in order for us to achieve this, it is important that we look into the seed systems. So the seed systems are not perfect. Farmers have to buy some of these improved seeds, and for really very poor smallholder farmers in Africa, they are not able to buy these seeds. But also we see that, given that households that adopt these improved varieties continuously over time, they obtain greater production, commercialization, and consumption. We also push for effective follow-up to ensure that there is sustained adoption. And talking about transaction costs, we're also highlighting from our work that there should be the improvement and development of rural and market infrastructure. And directly, we encourage the strengthening of various rural and farmer groups as they have the opportunity, as they have the ability to trigger a lot of conviviality and social networks, and by so doing, increase agricultural production, consumption, and commercialization. And with this, I would come to a close, but thank you very much, and I look forward to interacting with you. Thank you very much, GCAS. I leave here back to the United States with a lot of warm words from the people of Japan. They've been very kind since I came yesterday. I take these good words with me, and thank you very much.
TABE-OJONG様、ありがとうございました。TABE-OJONG様よりご講演いただきました。ありがとうございました。以上3名の受賞者の皆様からご講演を頂戴いたしました。どうぞ今一度受賞された皆様に盛大な拍手をお送りくださいませ。おめでとうございます。それでは以上をもちまして2023年若手外国人農林水産研究者表彰を終了いたします。会場の皆様にはこの後少々ご案内がございますので、今しばらくお付き合いくださいませ。本日はご参加、またオンラインでのご視聴誠にありがとうございました。